As you can see, it's another beautiful day in sunny Wales. Today, we're in front of our very own e-house. The reason we're here today is to actually show you a house that we've just constructed. And the reason we've built this property is A, to show you how all the renewables work. I mean, we've got air source heat pumps in here, we've got solar panels, we've got batteries, we've got electric car chargers. And secondly, it's just to create this knowledge so that we can share with the rest of the UK why we think now is an amazing time to get involved with renewables, whether you're an installer or a consumer looking to have these technologies in your home.
Here we are looking at a 3 kilowatt solar PV system paired up with a 6 kilowatt battery inside. This particular property is a 3-bedroom bungalow off gas, so run solely by electricity. The sun will hit these panels and generate enough power to either directly feed all of the lights and sockets inside or charge the battery and then provide the power required by the occupants to make a cup of tea. So how does this system work? When the sun hits these panels, it generates electricity. That electricity is then sent straight to your consumer unit, your fuse board. It goes from your fuse board into, let's say, your kettle. So if you want to boil a cup of tea at lunchtime, you will be using the sun's power to make that cup of tea. You will not be buying your power from the grid. Well, this particular system has got a battery backup with it. So you will then be using the energy from that battery, which has been generated from the panels in the day to make that cup of tea in the evening. Your system will always use the power from the solar PV panels or battery system first over purchasing power from the grid, provided there's enough power being generated in the day by sunlight or stored in your battery. So here we are inside our e-home looking at two pieces of equipment. We have the solar PV inverter and we have the backup battery. This here converts the electricity produced by your solar panels into usable electricity in your home. Any excess energy that you generate is then stored into this battery here. So for instance, in the evening when the sun is not shining, you'll be using energy from your backup battery to supply your sockets, lights in the home, making yourself a cup of tea, cooking, etc. If you find throughout the day that you've actually filled the battery and you're still producing energy, then you will be selling that energy back to the grid and getting paid for it via the use of smart tariffs. So for this particular 3-bedroom e-home, we've opted for a 3 kilowatt Solax inverter and a 5.8 Solax backup battery. We've got 8 405 watt panels on the roof, giving us 4 kilowatts. We generally oversize the panel array versus the inverter size. And the reason for this is we can then take into account the lower production in the winter months versus the higher production in the summer months. And what we're generally looking for is about an 80% balance of the panel to inverter input year round. Here we have our hot water cylinder heated externally by our air source heat pump. This will provide enough hot water for the residents in this property. Here we are at the side of our e-house looking at the heat pump. This particular heat pump will provide enough heating and hot water for this property year round. The heat pump works by compressing the air fed into the back of the unit, then expelling it from the front of the unit. There's a compressor inside. When the air is condensed, that condensation of air turns into heat, which is then fed in to the pipes into your property, into your radiators or underfloor heating. Paired up with this is also a hot water storage tank inside. What we've seen over the recent months and years is all the bad press about heat pumps. This we've found is primarily down to poor design. What we do is first off, before looking at the property owners or the heat pump itself, is we look at the property. What we're calculating is how much heat does this property lose. Then we match that with sizing the pump correctly to replace that heat. We do this by looking at the makeup of the property, the type of structure, the type of insulation. We get that right from the beginning, then we can size the heat pump properly. A lot of people think that heat pumps are quite noisy units. As we can see here now, I've got my meter on top of the pump whilst it's running. With me talking, it's about 60 to 70 decibels. I'll be quiet for a moment and let's see what it sounds like. So we've got an average reading now of 65. Manufacturer says about 61. We have got a bit of rain and background noise here, but as you can see, these units are pretty quiet. An average gas flue will be running at around about 70, and a typical 2 or 3 people talking will again be around about 60 to 70 decibels. Pairing this unit up with our solar, PV and battery backup system, we can really maximise the energy efficiency of this home. So we've calculated that this property has a heat loss of just over 2,500 watts. This 5 kilowatt heat pump will easily replace that 2,500 watt loss at a temperature of -2 degrees, at a flow rate of 45 degrees, giving us an efficiency of 3.65, or in other words, 365%. This means that when this unit consumes 1 kilowatt of electricity, it will provide 3.65 kilowatts of heat to the home. So what does that mean financially? Well, electricity is typically 3 times as expensive as gas, so we try to achieve a minimum of 300% efficiency. Anything above 300% efficiency, in this case 365, means it's actually cheaper to run the heat pump than it is a gas boiler year-round. So this is why it's so important to calculate these systems correctly at the design stage, because paired up with our solar PV system, and we really do gain the maximum efficiency of these combined units. A heat pump system similar to this will save you about £200 a year. We can come round to your home, design and install a system that will be right for you. The government is currently giving £7,500 towards all heat pump installs. To find out if you're eligible, contact us today.